Hi, my name's Alex Seidel. I'm the emissions engineer here at Aprovecho Research Center, and today we're going to learn how to calibrate the carbon monoxide sensors and how to re-zero the carbon dioxide sensors of the sensor box, one of the integral parts of our LEMS and PEMS systems. This calibration procedure is only going to be good for the sensor boxes numbered 2022 and above. If you have an older sensor box, you'll need different tools. You'll especially need a different gases to calibrate your sensor box. So if you're interested in calibrating one of those older sensor boxes, please contact Aprovecho for documentation and information on how to calibrate your older sensor boxes. For the carbon monoxide calibration, you're going to need some tools. One is your computer. The same computer you use to run tests is fine. Your sensor box, obviously, along with its power cord and the computer data cord connecting it to its computer. You'll need your tank of gas. This tank of gas has 300 ppm carbon monoxide and 3000 ppm carbon dioxide. The balance, the rest of it, is air. It's important to get a balance of air and not just nitrogen or oxygen, because for the calibration process and the sensors it has to have that balance. Attached to the tank you'll have your two-stage regulator. Also, you can get this usually from the same place you get your gas mixture. It's important that it be a two-stage regulator so there's a constant flow of gas during this process. Then you'll need some connecting tubing so you can connect both your sensor box and your two-stage regulator into their system. And then the last piece is a magnehelic gauge. You can use the magnehelic gauge already attached to your sensor box if you don't have an extra one, but most LEMS and PEMS should have been shipped with an extra magnehelic for calibration, with the needle centered vertically. A lot of these tools you can use for the IAP calibration as well, although the procedure is slightly different. You can contact Aprovecho for a copy of the IAP meter calibration procedure, which is very similar to this. The last two pieces of equipment you will need are a small flathead screwdriver to adjust the zero of the magnehelic gauge, and also a calibration processing sheet. It's an Excel document that you can find on the Aprovecho website. Next, I'm going to run through the procedure involved in calibrating the sensor box before I show you exactly how it's done. First, you'll get the sensor box running just like you would normally for a normal LEMS or PEMS test using the logger program located on your computer. And you'll let the sensor box run for 10 minutes in clean air. This is to allow the sensor box and the sensors inside time to warm up and obtain a background reading of carbon monoxide and carbon dioxide in the room. Next, you will pump the gas through the magnehelic gauge and into the sensor box, and you'll let the gas run for another 10 minutes to allow the CO and CO2 sensors time to get a reading of the gas. And before you disconnect the gas at the end of that 10 minutes, I'll show you how to communicate with the CO2 sensor and adjust the zero offset inside there. After we do that, we'll turn the gas off and allow the sensor box to again sample 10 minutes of clean air to clear the gas out of the system. After that, we'll process the data on the computer and obtain the calibration constant and zero offset for the carbon monoxide cell. And after we can obtain those values, I'll show you how to input them into the sensor box. And after that, we're done. So we're going to start our calibration now. You should have already connected your sensor box to power and to the computer. It should be all set up where you're going to do your calibration next to your gas tanks. And then we're going to open Logger, just like a normal LEMS or PEMS test. So we double click on Logger. And it's going to ask us, just like normal, to make a file name. So I'm going to call this, because we're doing a CO calibration and a CO2 zero, I'm going to call this gas cal, and then the name of the sensor box, which in this case is 2027, and then I'll put a date because in case we need to know or find our data later, it'll be nice to have a date to remember when we did the calibration. So it's 2014, it's on the 6th, and then, June is the 6th, and then today's date is the 26th. And then add .csv, don't forget that. So we click OK. It asks us to turn on the sensor box. There it goes. And we'll start it up. And there it's logging just like normal. And we are going to add, let's open live graph before we're done for now. All right. Okay, and now we want to open, go over here to open, and just like this is a normal LEMS or PEMS test, we want to open that file we just created, gascal 2027 on June 26th. There we go. So we're going to open it up, and then we're going to make sure our CO, down here in the data series settings, we're going to make sure our CO and our CO2 lines are selected. So red is our CO in this case, blue is our CO2. We see them going nicely. I'm going to minimize my other windows to get them out of the way because all I really care about for the calibration is the plot so I can see how it's going, and then my teraterm window as well, which will come in useful later. So right now all we have to do is wait that first 10 minutes till we can put the gas on and continue to the next part of the calibration. So we'll wait 10 minutes and then we'll show you what that looks like. Alright, so we have our 10 minutes of background data, or 600 seconds according to teraterm. If it's a little longer, that's okay. More background is always good. You just want at least 10 minutes. So before we get this gas running, we want to take a look at our magnehelic gauge to make sure it's ready to go. So you'll notice that our needle here is standing straight up, and that's good. If it's not, we can adjust it using this small flathead screwdriver and this screw down at the bottom of the magnehelic. We can adjust it till it's actually straight up by turning the screwdriver back and forth. You'll notice also that we've connected a T-barb, a T-junction, into one port of the magnehelic. That is going to be so we can balance the power of the sensor box with the power of the gas coming out of the gas tank. And by looking at the magnehelic, we'll be able to balance the two opposing forces. So let's get this started. So I have my tube from my gas. I connect in to one side of the T-junction. And now I can turn on my gas. It's very important to be in a nice, well-ventilated area because there is a little bit of carbon monoxide in here, and you do not want to fill your room up with carbon monoxide. We have some windows open. You can put a fan in, anything to ventilate the room a little bit and get a little bit of fresh air rolling so you're not breathing in that carbon monoxide. The levels of carbon monoxide have never been too high, but it's still something to be careful about. So I'll turn on my gas tank at the top. You'll notice our needle has jumped up here. It means that gas, we can hear the gas flowing. And now, whenever I want to adjust how much gas is flowing, I can use this knob, which you'll see me do in just a second. I have it flowing through my magnehelic, and now we're going to connect my sensor box into that magnehelic and get some gas flowing into the sensor box. So I connect one side of my tube. You can use the same tube that is part of your LEMS or PEMS system. We take the other side of the tube and connect it into the magnehelic gauge. So now you can see my needle is not straight up. So I can adjust the gas tank until my needle is straight up. And that means that the pressure from the tank and the pressure of how far the sensor box is sucking is balanced. And that's what I want for this calibration. Now I'll show you what it looks like on the computer when we've attached this gas into the sensor box. Alright, so we've gotten our nice background reading. You can see we have a nice flat output here. And we've just connected our gas, and you can see that our sensors are already responding. Our CO sensor up top is already starting to flatten out. Our CO2 sensor in blue is also going up. It's reacting a little bit slower, but it's still going. So now we just have to wait another 10 minutes for it to stabilize, and then we can go on to the next stop, which is communicating with the CO2 sensor. So as you can see, we have a nice stable flat output after putting the sensor box on the calibration gas for about 10 minutes, a little longer in this case. So yeah, you can see that flat output. We got a nice flat CO2 output. We have a nice flat CO output up here. So all we have to do before we disconnect the gas is communicate with the sensor box and the CO2 sensor inside. So we're going to go over to the TerraTerm window, select that, and you can either press the red button, the reset button on your sensor box, or quickly turn on and off the sensor box because we want to put it into calibration mode. So we're gonna cycle the sensor box real quick and type in CAL and hit enter. If you do that in the first 5 seconds, that means we've entered into calibration mode, and you have these choices that you see here. We'll get into them more in detail after we process our CO data, but for right now, all we need to do is communicate with the CO2 sensor. So that's what I'm going to do. I'm going to enter 4 for CO2 communication. You see that's the last menu option there, and then it asks us for a command. And all we need to do is tell it that it is looking at 3,000 ppm of CO2, and it'll be able to zero itself from there. So the command for that is capital X space 3,000 for 3,000 ppm. And after that, all we have to do is hit enter. It gives us a response back. It looks okay. And then we just have to disconnect the gas, which we'll show you in the next step. So after communicating with my CO2 sensor while the gas is still running, I can disconnect my gas, turn it off. I want to do this in a specific order so I don't make the sensor box work too hard. So the very first thing I'm going to do is just disconnect my sensor box from the magnehelic gauge. I've got gas coming out now, and all I have to do to turn off the sensor box is to turn this big knob at the top. Turn it down, and I can see the pressure inside my regulator dropping. And when it goes to 0, I know that I have no more flow going out of my system. So now we're waiting that 10 minutes for the sensor box to sample clean air, after which we can process the data. One thing about our two-stage regulator, I don't want to store any gas inside this regulator, or else it will damage the regulator, which is fairly expensive. So I want to make sure after I'm done with the gas every time that this needle goes back down to 0. If it stays up, that means I've got gas in my regulator after the test, which is no good. So if my needle is at 0, we're good, and it looks like we're good. So we'll process the data next.
Next, let's go over processing this calibration data. Once you've recorded the calibration data into a CSV file, it will need to be processed before it can be entered into the sensor box. The calibration procedure exposed the CO sensor first to a 0 carbon monoxide environment for several minutes, followed by a known concentration of 300 parts per million for several more minutes. However, the output from the sensor is in log units. As you can see in this graph, it goes from 0 to 6,000. We need to map this into a range of 0 to 300 ppm. To help simplify the procedure and reduce errors, a calibration template has been made available. To use it, navigate to your emissions output folder. Locate the template file and make a copy of it. Rename the template file into something useful, such as Next, open that file. Move the cursor to cell A1. From the Data ribbon, choose Get External Data from Text. From here, let's navigate back to your emissions output folder. You should be able to find the CSV file you recorded in the first part of the calibration process. Stepping through the menus, we know it's a delimited file. Make sure comma is selected, and keep the numbers in general format. Finish. Select cell A1 again, that should already be selected, and click OK. That should import all of your calibration data into the new worksheet. What we need to do is find an average of the baseline values and an average of the 300 parts per million values in the graph. We'll record those second numbers in this column here. To make it easy, you can hover your cursor over the lines and record the data points. In this case, we have 0.495, so let's enter that into the first box. That's when we'll start the average range. Here's a point we can use to end the average of the baseline, 0.849. So at 849 seconds, we'll enter the end of our averaging value. Next, let's find an average of the 300 parts per million section. Make sure the graph is leveled off and pick a value. 0.1549 looks good. Then find an end value. 0.1775 looks good. At this point, your calibration values will be displayed. The calibration content in ppm per log unit will be entered directly into the sensor box. The CO0 value will be used to adjust the value already stored in the sensor box. You can now proceed to record the values into your sensor box.
All right, on to the last part of our calibration procedure. I'm going to show you right now how to enter the CO calibration value and the CO offset that you calculated in the last part, and how to enter that back into your sensor box. So for this step, I'm looking at my computer screen. I've already connected my sensor box to the wall power, and I've connected it into the computer just like a normal test. But now instead of opening Logger, I'm going to use the TerraTerm communications program to communicate with my sensor box. So usually we got to check what our communications port our sensor box is connected to our computer with. Usually it's communications port 2, but if you're not sure, you can open Device Manager, double click there, and scroll down the list to see the ports. Here we can find out what port our sensor box is attached to. So I expand that. I see that in fact the only port connected is the sensor box, and that's on communication port 2, just like I said. If yours is a different number, that's okay. You just have to remember that number for our next step. So here we can exit Device Manager and open TerraTerm, double click. And now we want to open a serial connection on that port that we just looked up. So for me, it's COM2. If it's something different for you, you should enter in the number you saw in Device Manager. So I click OK, and now it's just waiting for us to start up our sensor box. So let's turn on our sensor box. In the first 5 seconds, we need to enter CAL and hit enter, and that gets us into calibration mode. If you forget to enter CAL in the right amount of time, you can reset your sensor box to have another chance to get into this calibration mode. And here we see our 4 options, our 4 menu options. Our first step is to go to menu option 2, the calibration value, and hit enter. And that'll give us a chance to see all the current calibration values that are entered into the sensor box. All I'm interested though in is in channel 0, the CO channel. So I'm going to enter 0 and press enter, and that gives me a chance to change the CO, the carbon monoxide calibration value. So for this example, I'm going to enter my new calibration value. This is going to be different for you, so just enter in whatever you calculated in the last section. I hit enter, and that's it. I can check the menu again to see if it entered correctly. So I go back to menu 2, the calibration values, and hit enter, and there I see my new calibration value for the CO in channel 0 right here at the top. That looks good, so I'm ready to go on to my next part, entering in the offset. So to end, I just click enter instead of a channel number, and that gets me back to the main menu, ready to enter the new offset. So now I'm going to enter that offset and go into menu option 3. There I see it, the offset menu. And there it's set up similar to the CalVal menu. I see my current carbon monoxide offset at -26469. This will be different for your sensor box, but it should look something like that. But you'll notice that usually the offset you've calculated at the during your calibration procedure is much smaller. So for instance, on this calibration, I got a value of -31. And all I have to do is, instead of entering that -31, changing the CO to -31, I just want to subtract that from my current CO value. So instead of entering -31 in this spot, I'm going to subtract that from our current calibration value. So I'm going to go to channel 0, which is the channel for the CO, and now I get to enter my new offset. So I'm just going to subtract -31 from this current number to get, let's see here, it'll be -26438 will be my new offset, because remember I'm subtracting a negative number, so it's going to be a little closer to 0. I press enter, and now again, just like the calibration value, I can check my offset. So I enter menu value 3, and there I see my new CO offset is entered and ready to go. And that's it. I press enter to get back to the main menu, and that's all I have to do. I can turn off my sensor box, and I've just completed my calibration procedure.
Alright, so you've seen the entire CO calibration, how to process the data, and how to enter it back into the sensor box. Thanks for joining us. If you have any questions about what you've seen, there's a document on the Aprovecho website, or you can contact us if you have specific questions about what you've seen. Again, a lot of this equipment that we've used here is also suitable for calibrating our IAP meters as well. It's just a slightly different procedure, which is also available on our website. And remember that if you have an older sensor box, again, you'll need a different set of gases to be able to do the calibration. So again, contact us if you have any questions about that. Thanks for watching, and I hope this helps.